So now let me explain that how you can use these use cases in EFFECTOR. EFFECTOR actually a framework for running large-scale experiments for the video streaming session in 5G environment, but also for the 4G as well. So I took one use case from here. There are a lot of use cases which actually on our GitHub repo. For example, indoor, mobility, outdoor, and pedestrian. So we took one use case of the mobility and run in EFFECTOR. So what EFFECTOR does, EFFECTOR will provide the quality of service KPIs from encrypted stream, and then we find the relationship between the quality of experience KPIs. Because in this paper, we only look at the channel level metrics. From channel level metrics, we predict the stalling events because we didn't rely on the QoS KPIs from the encrypted stream. So we find an alternative way of predicting the quality experience KPIs of the YouTube player in the wild. So the idea is use this realistic use case and put in EFFECTOR and then see what different kind of quality of service KPIs we can drive and find the relationship between the QoE KPIs. So I have just downloaded this VM from my GitHub repo. There's nothing on it. So let's move to the installation directory. So we have installed the software in the downloads, then go to go dashpad, and then you need to run the run.py file. So open the terminal. If you run this file, it automatically invoke the topology that we created, and also it created the OVS switches in an SDN environment, and then there are a lot of other settings we can set here. For example, so let me run the command. You need to run sudo python 3.run.py file. So if you go to run.py file, so let me explain what is inside run.py files. Actually, the parameter settings here. So the experiments is running in 5G environment that I have just explained to you, and number of hosts. So number of hosts streaming the video session simultaneously. So at this point, we just set 1, but you can set 2, 3, 4, 5, 10 according to your requirement. And then the algorithm is, if this is adaptive bitrate streaming algorithm, ABS algorithm. At this point, it's running in elastic, which is a hybrid based algorithm. Then we have buffer based, and then conventional is the throughput based. So we are running in elastic in this demo, and the use case, which is I just said that I took from this paper, and we are going to run in EFFECTOR here. And what else? So we have the protocol TCP, but you can also run same experiments in Quick, and let's see what's happening in Quick as well. So you will get an idea when I show the logs. And then in server type, it's the number of how many times you want to repeat the experiment. So the good idea is to run the experiments multiple times, so then you can take the average here. So you can also get an idea that there is a lot of loops here, because these are Python lists. So you can provide another value here. For example, I want to run the same experiments in VBA as well. So that means that everything is same, but it will create 2 experiments, one with elastic, one with the VBA. All right. So let me run the experiments now, and let's get straight to the logs. So I just put my password here, and now the experiment is running in the background. So it's also giving some statistics. So the experiment is running in 5G, and the use case is this one, number of hosts, the algorithms, and the protocol was TCP. So now where are the logs? Logs are in this folder. Go to data. You can also create your another folder and then just give the path to the folder. So the folder is also giving some statistic that what is inside this folder. So the experiments running elastic, TCP, and server type, and the 5G experiments. This is the pcap file. So we have experiments running, and we also passively monitoring the traffic as well. In this traffic is encrypted, and then these are the logs here. So you can see the logs. There are a lot of these are the quality of experience KPIs here, for example, and also in the form of segments, because now video are in the form of segments: 2 second, 4 second, 6 second, 8 second, 10 second, and then these segments are defined in an MPD file, and then the algorithm decide segment bitrate resolution and stall based on the network conditions. So at this point, the elastic first decided the segment in these resolutions, and the P.1203. This is a ITU model for the mean opinion scores. That's mean 1 is the lowest and 5 is the highest. That's mean at this point the mean opinion score is not very nice. And also few other qualitative experience model as well here in this log as well. So mostly we relied in on P.1203 here in this demo, and you can see that after few segments, this each segment is running in 512 and 288 resolutions, but now you can see that 11 segment is running in 1280 by 720, and then it jumps to 1920 to 1080 resolution, and the P.1203 score is get it started improving, and you can see here it's 3.4. So that's me and the experiments. There is lots of other KPIs here as well. For example, the buffer level. What is the buffer level of the player? And then what is the delivery rate, representation level? Is there any stalling event happened here? So during this session, I didn't experience any stalling event for this demo. Right. So now let me explain few more things about a factor. So the traffic is encrypted. This is what we know. Now what kind of features we can drive from this encrypted stream? So we again followed a pattern of window-based QoS feature extraction method. So for the 1 second window, we found 31 QoS features which are highly correlated to quality experience KPIs that I will show you in a few minutes. For example, we have these all features we drive in just 1 second window, and it's also we also drive few features from inter-packet gap. That's mean this is another novelty here, that we use only times between the packets, and we did the time series analysis and found these features. Okay, so let me show you the correlation. So before showing you correlation, let's look at the architecture of the system. So we have the video content here, and it's these are the Go-Dash clients, and then the KPIs and QoS KPIs and QoE KPIs that this framework provides to you. Now let me show you the relation between the QoS feature that we found. So we can see that initially the network condition was not good, and we can see also from the logs that these segments are running in very low resolutions, low bitrate, low mean opinion score, and the throughput, we can also from the throughput is a little bit not nice. And then we can see these spikes actually the relationship that at this point there is something is wrong at this point. And yeah, you can see at this point that is the quality of experience is not good, and we also experience stalling event. So this is another experiment, but actually what we are trying to show here in the paper, what I'm trying to show here, that this is how it works, that we if there is problem in the network, we experience low throughput, then spikes, low quality of experience, score of P.1203 model, and then we also experience stall here as well. So we can see that there is pattern that we drive from this encrypted stream. And yeah, so there are plenty of use cases available in this paper, and you can run experiments here in EFFECTOR, large scale experiments to draw multiple combinations, then look at the quality of service KPIs and quality experience KPIs. For instance, we can use machine learning models that can predict this whole video streaming session into low quality experience of the low quality experience, medium quality experience, and the and very nice, for example, for the whole video streaming sessions. But you can also look at the segment level statistics as well. So there are a lot of things to explore here. So what this framework is about, you can take the use case from here, from this. This is also a reproducible framework. Take the use case from realistic use case from here, run in EFFECTOR, and then draw a relationship between the quality of service KPIs and the quality of experience KPI.